Hello, the purpose of this video is to move from a visual example of perfect trinomials to completing the square, first visually and then algebraically. So we're going to start with something as basic as x plus 3 squared that you see on the screen, and that is a perfect trinomial. And we can see that it is literally a perfect square. We have x plus 3 times x plus 3, and we have this structure that we've been exploring for our area model, x squared, and then 3x and 3x here for 6x plus 9. We have a similar example here, x minus 5 squared, and we can see from the visual that x minus 5 squared is equivalent to x squared plus 10x plus 25, and the structure is the same. I have my x terms on this side and this side, the x squared top left corner, and my numbers on the bottom right, the 25. So I can see very easily x squared minus 10x plus 25. This is where we begin to look at completing the square. Look at this example. In this case, we have x squared minus 10x plus 28. That looks a lot like the previous image that we had, except that this time, instead of having 25 here, we have 28. We can see we have three more of these blocks here. So we can see that these could become x minus 5 squared, which is what we have previously, plus 3. And when we write it like this actually is vertex form. So what has happened was we can think of a function that is in standard form, like x squared minus 10x plus 28 being rewritten in vertex form like this, x minus 5 squared, which is the binomial square, plus these 3. And that would produce a vertex of 5, 3. Very friendly, I hope. Now we're going to look at another example. This case, we are short, we can say. Instead of having x squared minus 10x plus 25, we have x squared minus 10x plus 20. So I hope you can see that this is equivalent to our x minus 5 squared, but with 5 units removed, minus 5. So we're literally completing the square visually here by seeing what is missing in this case. So I would rewrite my standard form this way, x minus 5 squared minus 5, which produces a vertex coordinates of 5, negative 5. Okay, one more example. I hope you're beginning to see the pattern. Of course, here is evident because we have the visual. I know I have x plus 4 squared. That's the binomial I'm looking for. In this case, x plus 4 squared would produce 16 here, but I don't have 16. I have only 5. Well, that means that I would have to have subtracted 11 units from my perfect trinomial. So my vertex form would become f of x equals x plus 4 squared minus 11, removing the 16 from before, vertex at negative 4 and negative 11. And gradually, we are going to move from the algebra tiles that are so powerful visually to thinking algebraically. So in this example, for instance, we can visualize that if we had x plus 7 squared, our area model, or our equivalent to the models that we've been seeing, would have 49 in this corner. And then when we look at 49 compared to the negative 10 we have in this standard form, we realize that we would need to subtract these 49 and then subtract another 10, meaning we would have to subtract 59 or add negative 59 to x plus 7 squared to get the vertex form. So that would be a vertex form. The vertex at negative 7 and negative 59. Another way that this sometimes is written to facilitate things is simply like this. We know x plus 7 squared would have 49 as the third term of the perfect trinomial, and that's what we're trying to complete. So what we do is subtract 49 at the first step, meaning that our perfect trinomial would be empty here in this space where there used to be 49, and that means that it would be 0, and then I have the negative 10. So then if I do this calculation of negative 49 minus 10, I arrive at the same form that we had. Either way, we're gradually moving away from the algebra tiles, and I hope this is clear. Now, for the moment, we have been seeing only examples where our binomial square began with this middle term being even, but the process is really the same. So now, if I have a standard form equation like this, x squared plus 3x plus 5.25, I can anticipate that I need to figure out potentially what binomial x squared plus 3x might have come from. And by now we realize that we're looking at x plus half of 3x, which would be 1.5, which would be x plus 1.5 squared. And when I square 1.5, my outcome is 2.25. So if this was a perfect square, I would have 2.25 here. So then to get to 5.25, well, I need 3 more. I can see that. So that would become my vertex form. F of x equals x plus 1.5 squared plus 3. You could also have done the same with one extra step by subtracting 2.25 from the first step and then add the 5.25. We would arrive at the plus 3 either way. Vertex at negative 1.5, comma 3. So I hope this was useful and it allowed you to see visually and then gradually algebraically how we complete the square in these examples. Thank you.